Good evening, everybody, dear participants of our seminar. I'm delighted to welcome you to our April session. Today's long-awaited meeting with Professor Heinrich Wansing has been prepared by Elena Mishalova, the active participant of our seminar, and I would like to give the floor for the introduction to Helena, and we will continue to our discussion, speeches, and presentation of this topic. Thank you, Helena.
Thank you very much, dear colleagues. It's my great pleasure to introduce you speaker today, Professor Heinrich Wansing. Professor Wansing is a professor of logic and epistemology at the Department of Philosophy 1 at Ruhr University in Bochum, Germany, and at the same time distinguished professor at the Tohoku University, Graduate School of Information Sciences, Japan. And his main field of research is philosophical logic, in particular paraconsistent and connective logic. And I cannot help but say that Professor Wansing is my host professor here in Bochum at the Ruhr University. So I'm happy twice to see you here as a speaker today. And please, floor is yours.
Yeah. Thank you very much, Ellen. And first of all, I would like to thank the organizers of this wonderful seminar for giving me the opportunity to present a talk today. It's really a pleasure. And yes, so let me start. The title of my talk, as you can see, is Contradictions, Logical Consequence and Information Flow. And this is a topic from philosophical logic and to some extent also philosophy of logic. And yes, so I will start with an introduction where I present you a number of quotes from rather well-known philosophers and logicians, expressing some views of contradictions and inconsistencies. And you will see these are very critical views. And after that introduction, I want to present you a certain contradictory logic. That is a logic where one can prove contradictions, a logic in which certain contradictions are valid. This is very unorthodox, and I will try to motivate this logic and present it in a way that it makes it clear that this is a rather natural system, although it has this very unorthodox property of containing provable contradictions. And next, then, I want to address the question, are there true contradictions? And here by true contradictions, I mean contradictions that are actually true in the real world. And after addressing that question, I want to deal with the question whether there are valid contradictions that are necessarily true, in a certain sense, true in every model. And finally, I want to present a view of logic that is also sort of non-orthodox or non-standard, namely the idea is to see logic not as the study of truth preservation, but as the study of information preservation. So that's the plan. And as I said, I want to begin with some quotes. So in the history of ideas, or maybe I should say in the Western history of ideas, very early already in ancient times, inconsistencies have been met with some reservation and rejection. So what do I mean by inconsistencies here? I mean contradictions. And by a contradiction, I mean a pair of sentences A and not A. So a pair consisting of a statement and its negation. This way of putting it may prompt the question, what is negation? And that's a very interesting question. There's a whole literature on it. What is negation? For our purposes, it is enough to assume that the negation of a statement A expresses the falsity of that statement. So not A is here read as A is false. And here's a quote from a book by Nicholas Rescher and Robert Brandom from 1980, where they say the following. Since Aristotle's days, virtually all logicians and logically concerned philosophers in the mainstream of the Western tradition have had a phobia of inconsistency. They have been near to unanimous in proscribing it from the prescience of their logical and ontological theorizing, holding that toleration of inconsistencies would inevitably bring cognitive disaster in its wake. So contradictions, inconsistencies are really bad, is the claim, because they inevitably, unavoidably bring you cognitive disaster. This is a quote from Rescher and Brandom from 1980. But also, and maybe a bit more generally, inconsistency have been associated not only with cognitive disaster, but with irrationality, with theoretical irrationality. Here's a quote from the Austrian philosopher Ernst Mally. And in 1929, he wrote the following. Just as logic must not exclude contradictory judgments from its consideration, so deontic, so the theory of what is obligatory, must not exclude contradictory and therefore unreasonable demands from its consideration, for both do exist. However, theory must realize that no actual state of affairs corresponds to a contradictory judgment, and that no actually existing obligation corresponds to contradictory demand. So there are contradictory judgments, yes, this is granted, but they are seen to be, they are associated with theoretical irrationality. It's unreasonable to hold contradictory beliefs. That's the idea. But okay, on the one hand, one was afraid of cognitive disaster, but some philosophers also were afraid of practical disaster. So, for instance, namely Alan Turing, the famous British mathematician and logician, who is well known for many things, among others for the Turing test. In his 1939 Cambridge lectures on the foundations of mathematics, which Turing attended, Ludwig Wittgenstein had a discussion with Turing. And when Wittgenstein asked Turing where the harm would come from if one would use a logical system with axioms that lead to contradictions, Turing answered as follows. He said, the real harm will not come in unless there is an application, in which case a bridge may fall down or something of that sort. So there would be a very practical and disastrous consequence of working with a contradictory system of axioms. At least Turing was afraid of this. And here's one more quote from Karl Popper, the famous philosopher of science, who thought that the acceptance of contradictions must lead to the end of criticism and thus to the collapse of science. So the application of contradictions would lead to the collapse of bridges, and the acceptance of contradictions, according to Popper, would lead to the collapse of science. Now, one may wonder, what is then actually the problem with contradictions? Why should we be afraid of bridges falling down or science collapsing? And the major problem with contradictory premises and contradictory theories is that from the point of view of classical logic, from the point of view of the classical conception of logical consequence and also negation, such premises, contradictory premises and theories lead to triviality, absolute inconsistency, meaning that every statement of the language we are dealing with is derivable, or model theoretically, semantically speaking, that from contradictory premises or theories, everything follows. And that would, I think, indeed be too much. This indeed would be a disaster if we would want to work with a theory or apply a theory and just anything goes, anything follows. Okay. A trivialization, I think, yes, this may be seen as a disaster, but one should also say that if one really wants to argue that this is a cognitive disaster that leads to believing any statements whatsoever, or even a practical disaster that results in bridges falling down, then one would have to supply a bit more of argument, a bit more of reasoning, and to make this conclusion really to give this reasoning a bit more rigorously. Anyway, there are so-called inconsistency tolerant or paraconsistent logics that avoid the trivialization because they invalidate and reject a principle that has a time-honored name, a Latin name, ex contradictione quodlibet. So this is the principle. So if we have contradictory assumptions, contradictory premises of the form A and not A, then any statement B whatsoever can be inferred from that contradictory set of assumptions. And this is the disastrous inference, and inconsistency tolerant or paraconsistent logics reject ex contradictione quodlibet. So, and if then the contradictions would not allow you to derive any statement whatsoever, then it's not so clear that contradictions are disastrous, or at least they are not disastrous in this trivializing sense. Good, but also paraconsistent logic has been met with a lot of criticism and rejection. And here's a particularly negative quote from a well-known French logician, Jean-Yves Girard, who only a few years ago wrote the following. So it's critical not only of paraconsistent logic, but of philosophical logic in general. He says, philosophical logics, euphemism for the archipelago of self-taught logics, produce nothing but fishbowl truths. Just don't break the glass. There's even a schizophrenic variant, paraconsistency, where the fish, confined to their own bubble, produce nothing but post-truth. It's metabolic if you're fond of cooking, double punishment if you think about what you're inflicting on logic. So, okay, there are these inconsistency tolerant logics, but nevertheless, there are still quite a few people, including logicians, who are critical of them. Then one may wonder, if paraconsistent logics are dubious, how problematic are then logics with provable contradictions? Well, I will show you a particular example of a logic with provable contradictions. It's also noteworthy to say that this widespread rejection or criticism of paraconsistent logics has been increasingly shaken since the 1970s, especially by the work of a number of logicians, such as Newton da Costa in Brazil, Richard Routley, Graham Priest, and Diederik Bartens, for instance, in Belgium. And also in computer science, the attitude towards contradictions has changed or has been changing. An early contribution to making inconsistency tolerance respectable is a paper by Dov Gabay and Tony Hunter from 1991. And there are some later developments. And indeed, in that year, in 1991, the term paraconsistent logic has been included in the subject classification of the American Mathematical Society. So this is seen and can be seen as giving a kind of recognition to paraconsistent logic. So it is a respectable area of research now, but still, as we have seen, there are logicians who are very critical of it. Okay, good. So one of those who disagreed with the fear of inconsistency already in the early days of modern logic was indeed Ludwig Wittgenstein. And here's a quote from 1930. So Wittgenstein said, "Indeed, even at this stage, so even in 1930, I predict a time when there will be mathematical investigations of calculi containing contradictions. And people will actually be proud of having emancipated themselves from consistency." Now, it's not exactly clear what Wittgenstein here means by calculi. So one could understand not only non-trivial mathematical theories, say, that contain contradictions, but one may wonder whether he might also consider contradictory logical systems on which theorems are based. There actually are logics with provable contradictions. and model theoretically speaking, they contain valid contradictions. And these are systems which are nevertheless non-trivial. So not any statement whatsoever is provable or valid in such logics. And such logics are now called non-trivial negation inconsistent logics. And recently, Graham Priest suggested to call them überconsistent logics. I'm not very convinced of that term. But anyway, as I said, I will show you an example of such a non-trivial negation inconsistent logic. I will show you a proof of a contradiction, and then you can make up your mind whether you find this, this system natural and the derivation, the proof of a contradiction frightening or not. Good. So here we go. So I want to show you a certain contradictory logic, and I will start quite a while ago in the Middle Ages with Boethius. So in a book from 1951, the German philosopher-logician Karl Dürr presents, in translation of course, various sentences from Boethius' commentary on Cicero's topics that exemplify what is called the four inference schemata of the second group of conditional syllogisms. And so here we have four inferences that are really interesting. So we can look at them. So the first says, it is not the case that if it is day, it is not light, but it is day, therefore it is light. And the second is sort of similar. It is not the case that if it is not light, it is day, but it is not light, therefore it is not day. The third says, it is not the case that if it is not day, it is not night, but it is not day, therefore it is night. And finally, the fourth, on the bottom, it says, it is not the case that if it is day, it is night, but it is day, therefore it is not night. So these are remarkable inferences. And if we try to formalize them, then we get this. So actually, the philosopher Oskar Becker formalized these derivations as follows. And in particular, if we look at the last one, then we have that assume that not P implies Q. So it's false that P implies Q. Assume also P, therefore not Q. And Dürr remarks that Boethius endorsed modus ponens, yes. And then I think taking this second group of conditional syllogisms literally suggests, and maybe if it also reveals, an understanding of negated implication that is very, very special. Namely, not P implies Q is understood as being equivalent with P implies not Q. So if not P implies Q is equivalent with P implies not Q, then again, if you have as the second premise P, then of course modus ponens just gives you not Q. And this is unorthodox because in classical logic, one would think that not P implies Q means P and not Q. But according to Boethius, not P implies Q means P implies not Q. And this is then the key for deriving a contradiction, as we will see in a moment. So there was a review of a paper, by Dürr, a review written by Heinz Müller, a German mathematician, and he reads Dürr so as to have assumed that Boethius incorrectly, according to Müller, replaced not P implies Q by P implies not Q. And then Dürr, in an earlier paper, explains that with respect to these inferences, there are four equivalences to be mentioned, which Boethius seems to presuppose, and which from the modern point of view are not to be called valid. So they are not valid according to classical logic. But one could nevertheless take them seriously. And Dürr refers to these formulas as equivalences of negation. And here again, we have the one highlighted in red. So not P implies Q if and only if P implies not Q. This is a non-standard understanding of negated conditionals, of negated implication, and it will play a big role now in the derivation of a contradiction. So I'm afraid now I have a number of slides that look very formal. There are tons of formulas, but don't worry. Towards the end of my talk, I will come back to slides where we have not so many formulas and again some quotes. So here you see a number of languages on this slide. So there's a language called LDDL. It's the language of distributive lattice logic. And it's a very simple language. You have propositional letters, so elementary formulas P, and then you can form conjunctions and disjunctions. This is not very expressive, this language. If you go to the language LFDE for first degree entailment logic, you add the negation. So you can say not, and or. And then in the language of positive intuitionistic logic, int plus, you also can say if then. So you have conjunction, you have conjunction, disjunction, and if then. And then in the language of this logic C, which is the same language as the language of another logic that is called N4, you have all these connectives. Not, you can negate, conjunction, disjunction, and the conditional. You can say if then. So when you start from distributive lattice logic, you can either add the implication, then you get into positive intuitionistic logic, or you can add the negation, which is also called strong negation. You get this system of first degree entailment logic. If you take the full language and the classical understanding of negated implication, if you think of not A implies B as A and not B, then you get the logic that is called N4. And if you use this Boethian non-standard understanding of if then, if you think of not A implies B as A implies not B, you get this system C. And I think this is all very natural and very well motivated, because the language where you only have conjunction and disjunction, it is a very, very, very natural system. It can be described by certain inferences. Say, here's the list of inferences. From A, infer A. Yes, obviously, you can infer A from A. If you can infer B from A and C from B, then you can infer C from A. This is the transitivity of inference. Very natural. From A and B, infer A. From A and B, infer B. Yes, of course. And if from A you can infer B, and from A you can infer C, you can infer B and C from A. Yes, naturally. And here we have the introduction of disjunction, for instance. So from A infer A or B, from B infer A or B. And if from A you can infer C, and from B you can infer C, then you can infer C from A or B. And the last axiom says that conjunction distributes over disjunction. This is all very uncontroversial. It's a natural starting point. So you have a language where you have conjunction and disjunction. You can say and or. And now in this logic C, you have also the negation and the conditional. And here's the semantics of C. And this, I'm afraid, is a bit formal, but don't worry. I will not go into too much detail here. So for the semantics of C, this logic C, you consider certain structures, models, where you have a non-empty set of information states, I. These information states are ordered by a relation. It's a reflexive transitive relation. You can think of it as expansion of information states. And then we have two valuation functions, B plus and B minus, that are mappings, that map an elementary statement, a propositional letter P, to a set of states. So VP maps P to the states where P is true or receives support of truth, and V minus maps such a propositional letter to a set of states where P receives support of falsity. And then you define the notion that a model and a state from that model supports the truth of a formula A, and you simultaneously define the notion that a model and a state from the model supports the falsity of A. And here are the clauses. So a model and a state S from the model support the truth of P, of an elementary sentence, a propositional variable P, if and only if the model says that this is the case, if the state belongs to the V plus of P. And the state S in the model M supports the falsity of P if the model says so, if the state S belongs to V minus of P, the states that support the truth of P. The negation then is a toggle that switches between support of truth and support of falsity. A state supports the truth of not A if and only if the state supports the falsity of A, and a state supports the falsity of A if and only if the state supports the truth of A. This is also natural. So negation is a switch between support of truth and support of falsity, a switch between truth and falsity. For conjunction and disjunction, you have what you would expect. A state supports the truth of A and B if the state supports both the truth of A and the truth of B. A state supports the truth of A or B if it supports the truth of A or supports the truth of B. A state supports the falsity of A and B if it either supports the falsity of A or the falsity of B. And the state supports the falsity of A or B if it supports both the falsity of A and the falsity of B. The clauses for the if-then, for the conditional, are a bit more complicated. So a state supports the truth of A implies B. A state supports the truth of if A then B, if for every bigger information state, it is the case that either the state does not support the truth of A or it supports the truth of B. And a state supports the falsity of A implies B if for every bigger state, this bigger state either does not support the truth of A or support the falsity of B. Good. And then there's a lemma that says once a formula receives support of truth at a state, it also receives support of truth at every bigger state. And once this formula receives support of falsity at a state, it also receives support of truth at every bigger state. And you can maybe read this as once a formula is told true, once it receives support of truth, it remains to be told true. Once a formula is told false, it remains to be told false. And now we have the definition of semantic consequence. A formula A follows semantically from a set of premises gamma if for every model and every state from that model, if the premises receive support of truth, then the conclusion receives support of truth. So you read this as preservation of support of truth from the premises to the conclusion. Good. And now we are only 3 slides away from a proof of a contradiction. So I wanted to show you a logic with provable contradictions and a proof of a contradiction. And for that purpose, we look at the axioms for this logic. They are also very natural. There are 2 axioms that only show you the implication. It says that if A implies if B then A, if A implies if B, A implies if B then C, then if A implies B, A implies C. Here we have this elimination of the conjunction, A and B implies A and B implies B. The introduction of the disjunction, A implies A or B, B implies A or B, and the other axioms that give you the conditions for introducing a conjunction. If C implies A, then if C implies B, C implies A and B, and the axiom that for the elimination of a disjunction. Then there are axioms regarding the negation. So the double negation axiom says not A is equivalent with A. The negation of A and B is equivalent with the disjunction of the negation of A and the disjunction of B. So not A and B is equivalent with not A or not B. This gives you the so-called De Morgan laws. And then we have this remarkable equivalence, which we already saw with Boethius. Not A implies B, if and only if A implies not B. And we have the modus ponens, if A and A implies B, then B. And now we come to the proof of a contradiction. So the logic is paraconsistent. We cannot infer an arbitrary B from a contradictory set of premises A and not A. But it is also negation inconsistent. So look at this simple derivation. Number 1 is just an instance of conjunction elimination. From not A and A, we get A. Yeah? Not A and A implies A. Yes, of course. Not A and A also implies not A. Good. But then what was this non-standard axiom for negated implications? Not A implies B if and only if A implies not B. So if not A and A implies not A, then if we go in the direction from right to left, then not A and not A implies A. But if we have 2 and 3, then by modus ponens we obtain the negation of not A and A implies A, which is a contradiction to our first line, the axiom 4. So by making use of this non-standard equivalence, this non-standard understanding of negated implications, and otherwise only very uncontroversial principles, modus ponens and conjunction elimination, we can derive a contradiction. And therefore I dare to say that this logic is a natural example of a logic with provable contradictions. All the ingredients are clear, can be motivated, and are sort of natural. The only non-standard thing is this axiom that we already find with Boethius. And this is enough to obtain a provable contradiction. Good. Okay. Now let's come to less formal questions. Are there true contradictions? So are there contradictions that are true in the actual world, in reality? Maybe they are not provable, but they are true. There are philosophers who believe that there are true contradictions. And one of those so-called dialetheists is Graham Priest. And of course, when he claims that there are true contradictions, we are entitled to ask him, well, give us some examples. And he is ready to give examples. And one example is the so-called Russell paradox. So here the question is, does every arbitrary description of a property determine a set? That's problematic, as Bertrand Russell showed to Gottlob Frege in a letter from 1903. And the problem is that the description does not contain itself as an element, gives rise to a contradiction if one reasons in accordance with the law of excluded middle, which is valid in classical logic. And then if you assume the law of excluded middle, so A or not A is always the case for arbitrary A, then you immediately get the contradiction. So let R be the set defined as follows. It's the set of all X, all objects X, such that X is not an element of X, such that X does not contain itself as an element. And then by the law of excluded middle, this R, the Russell set, either is an element of itself or not. A or not A for arbitrary A. So R element R or R not element R. Suppose R is an element of R, then by the very definition of this set, it follows that R is not element of R. So if R belongs to R, then it belongs to the set of entities such that X is not an element of X. So R is not an element of R. So we suppose R element R and obtain R not element R, so we have a contradiction. But also if we assume R not element R, then by the definition of R, well, we see that R meets the criteria for membership in R. That is, R is an element of R. And again, we have the contradiction. So, and well, there are other examples. For instance, Priest also claims that legal situations can create true contradictions because we sometimes have inconsistent laws. And there are other examples, but we need not go into this. So Priest believes, and other dialetheists believe, that there are true contradictions. And then in the Stanford Encyclopedia entry on dialetheism, the view that there are true contradictions, this dialetheism is presented as the view that some contradictions are in some sense true in the actual world. And in a recent paper, Priest comments on dialetheism as follows. Of course, since the view about truth, since dialetheism is about truth, it does tell us something about the world, reality, if you like, in some sense. Note that I write the word with an initial uppercase to distinguish it from the world of formal semantics. So he's talking here about reality, the world. And then, okay, this was about the question, are there true contradictions? Now I want to deal with the question, are there valid contradictions? So, and for dealing with that questions, we have to consider models, because a contradiction is valid if it is true in every model. And in a paper 20 years ago or so by Priest, we can find the following remark concerning truth in an unqualified sense. So just truth, or truth in the reality, and truth in a model. And this is what he says. Being true in, so being true in a model, is quite distinct from being true, simpliciter, true in reality. The latter notion is a property, or at least a monadic predicate, and has nothing in general to do with sets. One might be interested in it for all kinds of reasons, which is unnecessary to labor. The former is a relation, and a set-theoretic one at that. And the only reason that one might be interested in it is that it is a notion necessary for framing an account of validity. We want to consider the question whether there are valid contradictions. The two notions are not, of course, entirely unrelated. One reason we are interested in valid inferences is that they preserve truth, actual truth. Hence, it is a desideratum of the notion of truth in the structure, truth in a model, truth in interpretation, that there be a structure, call it the actual structure, such that truth, simpliciter, coincides with truth in that structure. So, if we want to relate valid contradictions to dialetheism, which is a view about natural language and truth in reality, the validity as a set theoretically defined notion from model theory, it must be connected with truth simpliciter in actual situations. And for that purpose, Priest makes use of a notion of a veridical model or veridical interpretation. And this notion can be defined as follows. Can be defined if we think of a translation from formal language to natural language. So for formal languages, validity in a model is defined, but dialetheism is a view about natural language in the first place, so we have to relate the two. So if f is a structure-preserving function, is a function that maps sentences of a given language into a natural language, such as English, then if I is an L model or an interpretation, a model for which the truth of a L formula A is defined, then the model or interpretation is called veridical with respect to this translation. If for every formula A is true in the model, if and only if the translation is true in the actual situation, is true simpliciter, in the world, in reality. Good. So we have this picture. So we have maybe sentences of a formal language. They are interpreted as true or false in models, which we have on the top. But then we can translate the formal language into natural language. We have sentences of a natural language. They are true or false simpliciter, true or false in situations, parts of reality. And then the models just represent these situations. That's the picture that emerges. But now Priest assumes that there is the world. So, and parts of the world would then be parts of reality, actual situations. So if we start from a sentence of a formal language, we can translate them into a natural language. We interpret them as true or false in the veridical in the world, and then the world is represented or modeled by the veridical models. Yes, those in which the models in which such that truth in the model coincides with truth in the world. So that's Priest's conception. So for the existence of well-motivated contradictory logics, such as C, to strengthen the case for true contradictions that are true in reality, there have to be veridical interpretations. And this can be called a veridicality assumption, so the assumption that there exist veridical interpretations. But are there veridical interpretations? If there is the actual world, reality, then there should be actual situations and veridical interpretations. And who would want to deny that there is reality? That certain elementary sentences are not just true or false in a situation, but true or false in an actual situation, in part of reality, and therefore in reality. Who would want to deny that? Okay. Priest also considers other models, which are so-called Kripke models. Maybe I'll skip this. We can come back to this. And there he would then assume that there is a veridical Kripke model that somehow yes, models reality. I now want to come to the last part of my talk, namely information preservation. So, okay, irrespective of the existence or not of reality, so we need not deny reality, irrespective of the question of the existence of or not of reality, we can ask ourselves whether it is possible to make sense of non-trivial negation inconsistent logics and their valid contradictions without assuming actual situations, without making the assumption that there exists the real world and veridical interpretations or the veridical Kripke model. And I have suggested a view that I call dimathematism, and it's a view that addresses this question in the context of state-based models, state-based semantics, so Kripke models where you have sets of worlds or states. And there's also a view that I call strong dimathematism, and it's a view that is meant to make sense of non-trivial negation inconsistent logics that are defined for formal languages without thereby committing oneself to true contradictions. So if we are not committed to assuming that there is the veridical Kripke model, we are not committed to believe that there are true contradictions. And so this is dimathematism, but maybe I'll skip it and go to strong dimathematism. So I think that this is an informational view. Dialetheism is, in a sense, a metaphysical view because the idea is that there are contradictions that are true in reality, in the real world. Strong dimathematism is an informational view. Some languages and some contradictory formulas from that language are such that their truth is supported by every state from every model. That is where the tilde denotes negation. There are sentences from that, this should be a calligraphic L sentences, such that for every model and every state from that model, in the model state W supports the truth of both A and not A. And similarly then for the truth of not A. So there are valid contradictions. They are true their truth is supported at every state of every model. And I think that this can be held as an informational view because this idea of support of truth and support of falsity it can be seen as an informational notion, and I will explain that now. So this dimathematism does not come with a commitment to the existence of the actual structured piece of information or the existence of actual information pieces as parts of this actual big piece of actual structured information piece that represents the world in such a way that a statement receives support of falsity in it if and only if A receives support of falsity. What do I say? Support of falsity in it if a formula receives support of falsity, yes. This step would require an additional level of representation that is not needed for making sense of truth support and falsity support for contradictions, and in particular for a notion of validity of contradictions that captures the contradictoriness in certain well-motivated non-trivial negation inconsistent logics, such as the logic C that I showed to you. So one can think of Kripke models as representing something else than structured totalities of actual or non-actual worlds. This would be what Graham Priest has to maintain. I suggest that Kripke models can be thought of as representing structured totalities of information pieces. So this is the picture. We again may consider sentences of a natural language. We can translate them into a formal language. Then we can interpret or evaluate them as receiving support of truth or falsity at states from the models, from the Kripke models. But then the question is, what do these Kripke models represent? So for Priest, they would have to represent structured totalities where each contains a unique actual world or other worlds. So really something that has a metaphysical status. But I think one can just maintain that these models represent structured totalities of information pieces. Of course, you have to say then what an information piece is, and we can talk about this in the discussion if you like. And so this distinction between support of truth and support of falsity, it is echoed in a certain metaphor that has become prominent in the 1970s due to seminal papers by Newell Belknap. And Belknap suggested to assign to sentences 4 semantical values, T, F, N, and B, which have an informational reading as told values. So N is to be read as neither told true nor told false, F as told false, told only false, T as told only true, and B as told true and told false. And then these values are given to elementary sentences. They are told true or told false, or neither told true nor told false, or both told true and told false. And then this assignment is extended to complex statements by certain recursive clauses. And then reconsider the definition of semantic consequences, of semantic consequence. So in this logic C, A follows semantically from a set of premises gamma if for every model and every state from that model, if the premises receive support of truth, then the conclusion receives support of truth. This does not mean, this need not be understood as if the premises are true, then the conclusion is true. Instead, we can read this as follows. Whenever the premises are told true, then so is the conclusion. Whenever the information given that the premises are true, then the information is given that the conclusion is true. And then, against the background of this logic C, the information that A and not A implies A is true, and the information that it is false, they are always given. A, not A and A implies A is always told true, and its negation is always also told true. So it's both always told true and always told false. This does not mean that therefore there are true contradictions in reality. I will skip the next 2 slides and come maybe to something that is also interesting for our discussion. So I have to admit that Priest's understanding of valid inference is the prevailing conception of validity. So semantic consequence for formal language is usually understood as truth preservation in all interpretations. That is, all models from a given class of models for which truth of L formulas is recursively defined. And if there is a veridical model, if there are veridical models, then validity guarantees that a valid consequence preserves truth in reality. Good. But next to the assumption, next to this veridicality assumptions for models or Kripke models, this standard understanding of validity which is an integral part of the dialetheism. If one wants to argue that the existence of well-motivated, non-trivial negation inconsistent logic strengthens the case for dialetheism. So to get the connection between truth in reality and validity as truth in all models, you have to assume this, you have to make this veridicality assumption. But I think you're not forced to make this assumption. With the idea of valid inference as information preservation, or maybe more metaphorically speaking, information flow, what the validity of an inference guarantees is that if the premises of the inference receive support of truth, then so does the conclusion. So, okay, falsity support is here in brackets because you can think of preservation of support of truth from the premises to the conclusion, but also you can think of and consider preservation of support of falsity from the premises to the conclusion. And this can be read as information preservation instead of truth preservation if you do not want to make the commitment to the veridical Kripke model, the assumption that there is the veridical Kripke model or that there are veridical interpretations. Yes. This informational understanding of valid inferences is a minority view, but it is shared by some philosophers and logicians, and one of them is Edwin Mayers. And here's a quote from Ed Mayers, where it says, validity of arguments should be thought of as information preservation rather than truth preservation. So one can then wonder, well, what does that mean? So according to Priest, evaluating the validity of arguments understood as truth preservation is the canonical application of logic. So that's why we really are interested in entailment, because entailment, valid semantic consequence, guarantees that truth is preserved. And he said that if information preservation does not imply truth preservation, then information preservation is not so useful as truth preservation. But if valid information is information preservation, and information preservation does not imply preservation of truth simpliciter, truth in the real world, then I think the understanding of logic as a theory of information preservation, although it is not available for the canonical application, it is nevertheless of some use because it's available for reasoning about information extraction from databases. So we are interested in the question, if we are given some information, does it also provide some other information? Can we extract information from a database? And this need not imply truth information. That's at least what we obtain if we are in favor of this dimathematism instead of dialetheism. Thank you very much for your attention. I'm happy to come back to slides that I skipped.
Thank you for your brilliant presentation. I am sure that there are many Ukrainian philosophers who is not here today will view your presentation, and just now we can discuss the points of your speech and ask question, give arguments. Please, who would like to start? I remember Nadia Kazachenko first. Yeah,
And there was a question in the chat.
I know. Please, from the chat, our participants, Olena Kalantarova, he came early, but your questions. I would like to ask the following question. I will watch the recording for the answer. How can Gödel's incompleteness theorem be philosophically interpreted within the context of his research?
Oh, that's a very, very, very big question. I mean, Gödel's incompleteness theorems have been discussed a lot in philosophy of science and epistemology. I'm not sure what I'm supposed to say here. I mean, the incompleteness theorems show some limitations of the formal method, it is usually said, yes, but I do not see that this is very directly now related to the issue I wanted to discuss in my talk, namely how to make sense of logics that allow one to prove contradictions. And I mean, these, as I pointed out, contradictions have been met with a lot of reservation and rejection. And now if someone comes and says, hey, there are non-trivial logics that allow one to prove contradictions, and they are well motivated, so it's theoretically rational to take them seriously, to consider them, to study them, maybe to work with them. So this is not. I do not see the immediate connection to Gödel's incompleteness theorems. I must say, but so I'm afraid I cannot give you a good answer to the very general question you're asking. I'm sorry. Yeah.
Thank you. And Dmitro Shishkovsky and Christoph Lumer and Anna. Dmitro, please.
Yes, thank you very much for your presentation. I would ask you to clarify the concept of informational pieces. So please, if you can.
Yeah, that's a very good question and a very, very appropriate question. So what is a piece of information? So actually, I have some material on this, but it would have been too much to present it today. So basically, I think that a piece there's a quote from there's a nice quote from Michael Dunn, who says, so that there's this very well-known but also controversial notion of knowledge that is often traced back to Plato. Knowledge is justified through belief, the JTB analysis of knowledge. And so an agent knows that A, if the agent, if A is true, if the agent believes that A, and if the agent is justified in believing that A. And Dunn says, well, information is what remains of knowledge if you remove justification, truth, and belief. So one could say, well, then nothing is left. No, but the proposition is left. So, and indeed for Dunn, a piece of information is something like a Phrygian thought. So that's also something I'm very much in favor of. So the information conveyed by a statement is the thought expressed by the statement. And yes, but of course you're right. I mean, this is then if one endorses or advocates an informational understanding of entailment, of semantic consequence, then yes, one has to say something about the notion of information. And yeah, so roughly, basically, I would say I agree with Dunn that a piece of information is a Phrygian thought. Yes.
Thank you.
Thank you. Christoph Luhmer, please.
Yeah, thank you very much, Heinrich, for this brilliant talk. I'm not a logician, therefore I had some difficulties even to follow, and still much more to be able to get into it very deeply. But I have a question regarding the sense of all that. So, practical sense, why do we need that? And so I would say we have two levels here. The one is the traditional logic, and the other would be I would not call it a logic, because I think this is perhaps a much too expensive usage of the word logic, at least as I understand logic usually. But we have a model of dealing with information. And that is a different thing. And I think we should separate these things and use the traditional logic as the basis for the second larger, let's say, a model of dealing with these things, where we have all these other concepts like justification and retracting beliefs and things like that. And think we should not confuse these two things, and I'm happy with doing such a work and modeling these kinds of dealing with information, but I wouldn't call it a logic, and I wouldn't think that it touches in any way what is happening then in logic, is the second kind of model. So that would be my idea about this, and I would like to hear your comment on that idea that I made out of what you said. Thank you.
Yeah, thank you for your question. Okay, you're also raising a rather fundamental question, namely, what is logic? And there's by now a rather extensive literature on the question, what is a logical system? And normally logicians would say, well, a logic is a task and consequence relation, or many would claim that logic is a task and consequence relation. So you need a language, and then a relation between sets of formulas from that language and single formulas, and this relation has to satisfy certain properties. Good. Of course, there's also a notion of logic that is much broader. And I think you started by asking what is this good for? What is an application? I think. And so I mentioned that these inconsistency tolerant logics, that they are now that they have found interests of computer scientists. And the problem is really pressing. I mean, we are confronted with inconsistent information. So I mean, the examples abound. I mean, so you look at your weather app on your phone, and it says, well, it will be raining in the afternoon, and then you have some other information source and says, well, it will be sunny, and then you have to make up your mind whether you take an umbrella or not. So we are confronted with inconsistent information, and just applying classical logic wouldn't help, because then the information, the inconsistent information would give an information explosion. So you could derive everything you want to. So there's also some practical need to deal with inconsistencies, and there are different perspectives on it. One perspective is you try to make your information consistent so that you can apply classical logic. And a completely different approach is that, but take the data as you get them, but use an inconsistency tolerant logic. So okay, this is one thing. So but this is in the first place about paraconsistent logic and whether they are useful. But then there's this more philosophical or metaphysical question: are there so paraconsistent logic is one thing, and Priest believes that if you think that paraconsistent logic is good, then hey, there's a slippery slope that by thinking about the matter will bring you to what he calls dialetheism, the view that there are true contradictions. Good. This is a controversial issue, but then these there are not only these paraconsistent logics, but there are by now quite a few systems that allow one to prove contradictions. These have not been receiving much attention until recently, but now it's clear that there are some systems. So this so-called connective logic C that I presented. There's also another family of logic that's called abelian logic, where one can prove contradictions, and other systems. And then the question: if this dialetheism is already so controversial, what happens if you then are ready to grant that there are provable contradictions? What does that mean? And are you then, Priest, of course, believes that the existence of such negation inconsistent logics, yes, this is they make a case for dialetheism. And my question was, hey, can one make sense of logics with provable contradictions without a commitment to dialetheism? And I think one can. And if one wants to, then one would have to, I think, replace this idea of logic as truth preservation with conception of logic as information preservation.
No, I got that. Sorry if I reply very briefly. No, I got that, but I think you could do it in a different way. You simply say we have logic as a system of truth preservation propositions, but on the other hand, we have, of course, these contradictory information and so on. That is all granted. I agree with that, but we can deal with this in a different way. So we are looking at the justifications people provide for their assertions, and then we abandon those which have the weaker justification. And that would be a completely different thing without speaking of a logic which permits contradictions in any sense. Yeah.
Yes, of course. As I'm happy to grant that there are different ways of inconsistency handling or reacting to emerging contradictions. Yes, but I also think that yes, that not only paraconsistent logic is one way one can go, but also that one can use logics where we have provable contradictions, that this is still rational, that this can still be rational, and but then the question, now I'm repeating myself, the question I was asking myself: does this then really force one to become a dialetheist? And I think it does not. So what I wanted to look into and investigate is if you want to avoid a commitment to dialetheism, what could that then? How can one then make sense of these systems with provable contradictions? And I think one can make sense in these informational terms. Good.
Thank you very much. So we should continue that in a different occasion. Thank you very much, Heinrich.
Thank you. Anna, please. Anna, your question and comments.
Good evening. Thank you very much for the wonderful talk. Few short questions about diamathematism. Do you consider it as both allowing compositionality and forbidding it, dependent on whether semantical or metaphysical context appear more relevant? From your presentation, it looks like semantical and metaphysical options you do not build a special priority between them, or do you? Do you still take semantical, let's say, level as a representational mean for metaphysical consequences, or not? And the second question, and maybe it clarifies what I'm curious about. So in the end, or one of the final main conclusions is that valid inference implies preservation of information. What would be the opposite of preservation information? How would you call not preservation of information? And to make it very trivial, sorry if it sounds quite radical, would not preservation of information mean not valid inference? Thank you.
Yeah, thank you for your questions. So there was more than one question. So on the compositionality, and I didn't mention compositionality, and actually diamathematism is does not make any claims about compositionality or non-compositionality. I mean, there is a discussion in natural language semantics whether the semantics of natural language is such that we may assume compositionality of meaning. Many people think yes. Some raise doubts about this, but diamathematism is not really related to that question. So the semantics I presented it's standardly compositional model theoretic semantics for this logic C. But what I do suggest is to detach semantics from metaphysics. So Priest he assumes that there is the veridical model that connects model theory to reality, to the world, and so he denies. Well, he's also not super consistent, I would say. You find passages in his writings where he says that dialetheism is a metaphysical view, and elsewhere he denies this. But anyway, he does not deny, of course, that there is reality, and yes, and the connection to as I mentioned also in the talk, the connection between model theory and dialetheism is that he assumes that there is a veridical interpretation or the veridical Kripke model, if you consider Kripke models. And I think that one can detach semantics from these veridicality assumptions, as I call them. So that was one of my main points. And so what if we have if we reason in a way that information is not preserved? So if we reason in a way such that truth is not preserved, usually people speak of fallacies. And so I haven't thought about this, whether I would also be ready to talk about fallacies. But yes, I mean, and Priest would say something is going wrong with the reasoning, and many other philosophers and logicians would agree something is going wrong with reasoning if it's not truth preserving. Well, this is, of course, a value statement. I mean, if you say that something goes wrong. But of course, yes, we can draw the distinction between reasoning where information is preserved and reasoning where it's not preserved. And if it is not preserved, maybe it's really it's better. I mean, if your reasoning at least preserves information. So I have no obvious idea what information, what reasoning that does not preserve information could be good for. Yeah.
Thank you, thank you. Yaroslav Shramko, please, and Andrei Vasilchenko, and after that, Dmitry Lishenko. Please, Yaroslav.
Yes, thank you, Heinrich, for a very interesting talk. So I have one remark and two questions. And my remark is connected to the question Dmitry Shishkovsky about pieces of information. So there is a tradition, quite a long tradition of interpreting these entities in semantic structures as pieces of information, which is connected to relevance logic and Rautley-Meyer semantics. So they explicitly say that explicitly substitute talking about worlds in Kripkean sense as talking about pieces of information and setups. They called these setups. So and then it also leads to changing binary accessibility relation to ternary accessibility relation. So I think this is in line your so to say, terminology is in line with this tradition. So this is my remark. And I have two questions, one a little bit technical and another general philosophical. So my more logical question is that if you now, so traditionally, indeed, the business of logical entailment is truth preservation. But if we again substitute it by information preservation, that still do you believe and or do you think that we are still interested in distinguishing between truth and falsity, not just preserving any information? By this preservation of information, still to track whether truth is preserved or falsity is preserved, because if we have a mixture, then it is very much close to this triviality story. And then the question is whether such logics which contradictory, like the system C, does give technical logical means to distinguish, to keep apart truth and falsity, so that to take this track and not to lose, to get into the mixture of truth and falsity. So this is my logical question. Mm-hmm.
Okay, so I try to keep track of your questions. Okay, information. So why is it interesting to consider the preservation of support of truth and the preservation of support of falsity? Actually, I skipped some slides where I say that they are on a par. So actually, we have two semantic consequence relations, a positive one and a negative one. But this is something I skipped. And now, what's your question? Why is this then?
So such contradictory logics, like system C, gives us means to take this distinction between truth and falsity, so to say, to not just preserve any information, but to distinguish in the course of such a preservation, to distinguish between preservation of truth and preservation of falsity.
Yes, so actually, yes. I mean, I consider logic such as C as models, as modeling really a preservation of truth and preservation of falsity. But what would it mean to preserve any information? What would that mean? I mean,
if you just tell or speak about preservation of information, so then there is a danger that we just say it's not important what kind of information it is, whether it is true or false. The main thing, it is an information. We just preserve information, but what is the sense of preserving false information?
Oh, that's okay. I think I see your point. I mean, if you want to infer, say, from A and B, C or D, then I don't see what is preserved if you do that translation.
Exactly.
A and B or C. But I mean, okay. So, okay, in these two consequent
some information is preserved, but we sometimes we can lose this and don't to lose this distinction between truth and false, this preservation of any information.
Yes. But after all, I'm still talking about support of truth and support of falsity. So it's not that this truth and falsity talk is completely avoided. And yes.
But syntactically, I mean syntactically.
Yeah, I mean, okay. I find this a sort of puzzling question, Jaroslav, because I mean the idea would be that there are statements that carry information. So, and then the information preservation would be the preservation of the information that a statement is true, but also the preservation of the information that is that the premises are false. Is then guaranteed that the conclusion gives the information that the information carried by the conclusion is false information. I think I have to think about it. Yes. But
thank you. And my second question is a general philosophical question. So it's about rationality. So at the beginning of your talk, you just mentioned that very often as a contradictoriness, as a consistency is considered to be a criteria or the very important property of rationality. And even, for example, such a powerful topic or area of research is belief revision. They consider belief sets, and they have a notion of rational belief sets. And there are two conditions. So closure under the logical entailment, as a consistency, relational consistency, and relation of consequence relation. And second condition is consistency. So what if? So do you think that we just give up this criteria or this condition of consistency as criteria of rationality, and then the rational, for example, rational belief set is just a set of propositions that which is closed under the logical consequence, or we should take some another criteria or some another condition instead of condition of consistency. Yeah, this is. Or we don't need the notion of rationality.
Okay, yeah. Okay, I mean, a par-consistent logician could, of course, say, yes, the closure under logical consequence should be closure under a par-consistent consequence relation. So that, yes, we could just accept any set as a knowledge knowledge base, and need not first try to make that that knowledge set consistent in order to apply a non-par consistent logic, but we could just work with belief sets and apply a par consistent logic. This is one thing, but then another. But what is also related is the understanding of a theory. So if we want to keep our theories consistent, then we can reconsider the notion of a theory. And as you may know, there is a paper by Andrew Tedder and Franci Mangraviti where they consider consistent theories over certain inconsistent logic. And but this works only if you have a conception of theory where the theory need not be regular. It need not contain all the theorems of the underlying logic, because were it regular, it would contain then the contradictions if the logic is contradictory. So I think what I definitely want to maintain is that it is rational, that I think it is rational to take seriously non-trivial negation inconsistent logics. Whether this need not mean to work with the notion of theory such that then every theory is also inconsistent. Does this at least partially answer your question? Yeah.
Thank you. Thank you. Mm-hmm.
Thank you so much for this question and discussion. And let's go on. Andrei, please, your questions or comments. And
Heinrich, thank you very much, Heinrich, for this talk. It was very interesting. I have my question is about. I understand we cannot dive too much into technical issues, but maybe you can give a general idea. You, as I got it, you propose this your information flow approach is in some sense as an alternative to veridical interpretation. Am I right? If so, what when we turn from veridical interpretation approach to information flow, what does this turn change axiomatically and semantically?
Yeah, that's also an interesting question. So take the example of this paraconsistent negation inconsistent logic that I outlined in my talk. So I suggest to read the semantic consequence relation of that logic in informational terms. Could one also read this in with an understanding of semantic consequence as truth preservation? Priest would do that. So Priest, his favorite logic is the logic of paradox, but I think he also thinks that this logic C that I presented, that he also thinks that this is rather naturally arising and to some extent well-motivated logic. So the distinction between logic as a theory of truth preservation and logic as a theory of information preservation or information flow, it need not lead you, I think, to completely different logics. It is just a distinction that I see at the level of the philosophy of logic. And
thank you. Thank you.
Thank you, Dmitry Lishenko, and please present yourself, Navrotsky. I
will present.
Yeah, of course.
Okay.
Dmitry.
Yes, thank you very much, Heinrich. It was a very interesting talk and very informative, actually, and actually very good one. Actually, I could use it. Everyone could use it for the students, for conference, because there were lots of things which could be used for different auditories. And I have several questions. First of all, you mentioned that when you ask about information, what is information, you mentioned Frege's thought. Does it mean that you apply, in your metaphysics, you apply some kind of Platonism, as we all know that Frege interpreted his thought platonically? This is the first short question.
Yes, and this is also a very good question. I'm afraid, because I mean, so when I say I want to detach semantics from metaphysics, maybe I'm making a bad deal. So I want to avoid a commitment to the reality or the world with capital W, and then what I'm in the end committed to is something like Frege's realm of thoughts. Yeah. I'm not sure. Maybe you're right, but on the other hand, I mean, what is?
I don't think that it is bad, actually. Actually, could be interpreted differently. But I mean, did you give a thought about this? I mean, are you a Platonist maybe, or you, I mean, in your own some specific way? It's not bad, actually.
But yeah, okay. This brings one really to also to the question. So if one wants to minimize metaphysical assumptions, how
Yeah.
far can you take that? So we are considering languages. So we are talking about the meaning, so the meaning of the logical operations, maybe the meaning of non-logical vocabulary, and then it seems hard to avoid to assume that there are languages.
With propositions, which, yeah.
So what is a language? I mean, the language is not when if you use ink or chalk to write a word, then well, the words do not consist of these ink or chalk. I mean, if the languages already are abstract entities.
Yeah.
And
Actually, yes. Yes.
So and then if you consider, for instance, canonical models, I mean, okay, they then you have then you have if you consider canonical Kripke models, you have states or worlds. Okay, so but so priest is not worried to assume that there is the real world and that there are other worlds that are also of a similar metaphysical status. But how do you build your states or worlds if you construct a canonical model? Well, there are sets of what you cannot avoid, sets of sentences. So yes, so in the end, it's difficult to get completely rid of metaphysics, but maybe it's good to try to minimize the metaphysical assumptions. And I think there's a clear distinction between say facts, assuming facts, and information about reality or so.
Mhm.
But I think you have a point. Yes. Does this informational understanding of logic not also come with some metaphysical commitments? Yes,
Yes,
maybe.
it commits us to some kind of Platonism. But actually, the problem is that standard model logics, Kripke models, they assume some kind of realm of proposition from which we define the true satisfaction of our formula as a subset of these possible worlds. Or vice versa, if you understand it set theoretically, for example. But I like to ask another question. You mentioned about the world when you were talking about priests' views. You were talking about the world with a capital W. Yeah. And
Yes.
if we understand, for example, if we can interpret the par-consistent logics with the semantics where we took as our models non-standard semantics, like impossible world semantics, we actually can do that. Does it follow that, and in some interpretations, they are not entailed in, no, as you were saying, as par-consistent logic, they are not closed under the entailment, at least non-monotonically, for example, closed under the logical entailment, yes? And under some interpretation, we can interpret that the world with a W, with a capital W, doesn't exist, actually. Or at least as Priest himself says, that it is a paradoxical entity, some kind of paradoxical entity, which is true because some false propositions, some paradoxes, they entail that true propositions, false propositions are true. Could we could we interpret paraconsistency in this way, through impossible worlds to the non-existence of the world with a capital W?
I'm not sure, man. I had some discussions with Graham Priest about this, and he said that it would be crazy to deny that there is the world. I mean, there is something rather than nothing, and what there is the world. So,
but it is paradoxical. The world that mereologically is a mereological sum of everything, including itself, as a mereological sum of everything, gives us the infinite regress, and in some way it includes its own non-existence as its own state.
Yes, so I'm definitely not an expert on this. I mean, Graham Priest has this book about paraconsistent metaphysics and gluons, which is
the one. It's
the one book.
Yeah.
So I've heard some presentations on this, but I'm not an expert on this. But
it's very complicated, very interesting, but in some ways complicated. Paraconsistent gluons, very interesting things. And the final question, at least for now. Wait a second, please. You are saying that you would like to be very parsimonious about metaphysics, but nevertheless, what meta ontology stands behind your views on? I mean, how do you define existence? Because as we know, Priest define existence as a non-neist. He says that there are objects. He is a neo-Meinongian, and he believes that there are things which do not exist, but they are somehow can be presented as objects, like Alexius Meinong was saying, and so on. What is the meta-ontology, if not behind your logical and metaphysical understanding of this information logic?
I'm afraid that I do not have a meta-ontology. I think what I want to make is a rather modest claim. So I mean, as I said, I wanted to make sense of these non-trivial negation inconsistent logics where you have valid or provable contradictions. And so this is about the meaning of the logical operations. And what I want to maintain is that you can make sense of the meaning of the logical operations without a commitment to the existence of these veridical interpretations. That's a modest thought I want to propose, and I would like to defend. So I'm afraid I have no worked out meta-ontology that I could offer you. Sorry.
Okay, thank you. And just remark, maybe question remark. If you're talking about veridical interpretations, we are talking about some kind of truth bearers, which must be true in some model, for example. But eventually, we cannot not think about how do this model, why these models are true. We can talk about truth makers. Eventually, even if these truth makers are ill-defined, non-known, for example, or fictional for some reason, or we are just neutral in our metaphysics, but nevertheless, if there are truth bearers, there must be truth makers, which make those truth bearers true. And eventually, we can work, of course, everyone can work without thinking about metaphysics or denying metaphysics or being parsimonious about metaphysics, but nevertheless, this is a legal question here. I mean, yes.
But when I say the picture I have in mind is, okay, there are bearers of support of truth and bearers of support of falsity. And these are, of course, the statements of the language you're considering. And then there are sources of information about these thoughts.
And this information, yes, as we were talking about previously, it's a kind of Platonic propositions which make those statements true or false. These are eventually could be interpreted. Those things could be interpreted as truth makers or truth or false makers, for example, of those propositions. And this is some kind of ontology, metaphysics.
Yes, I mean, so if part of the picture are sources of information, and so something tells sentences true or statements true, yes. So these are support of truth providers, maybe not true makers or falsity makers. But yes, so something has to be assumed there. That's true. Yes. So there is maybe.
Dink and sich, like at least like Dink and sich. Yeah, okay, thank you very much. Thank you. Yeah.
Thank you so much. All of our questions, it's an invitation to the future discussion. Yes, and our next question.
Volodymyr. My name is Volodymyr.
Yeah, thank you so much.
Good evening. Thank you for your presentation. Let me give you an example and then ask one question, also practical question. First argument, withdrawing the US Navy from Strait of Hormuz will increase the threat of terrorism. Therefore, the US Navy must not be withdrawn from there. Second argument, withdrawing the US Navy from Strait of Hormuz will reduce the threat of terrorism. Therefore, the US Navy can be withdrawn from there. The conclusion of the first argument defeats the conclusion of the second argument. At the same time, the conclusion of the first argument is defeated by the conclusion of the second argument. So both conclusions are defeated. My question is, how can one make a rational choice in such situation? For me, problem is that we can provide supporting information for both arguments. And finally, both arguments remain defeated.
Okay, this talk about defeat of arguments is of course an issue in argumentation theory.
Yeah.
So this is not my topic. So I mean, I'm definitely not an expert in argumentation theory. So I'm not sure what I really can say. Could you maybe condense what you're asking in a single in a question, in a complete question? I'm a bit lost, let's say.
Can one make rational choice in such a situation?
Talk to a person who's an expert in rational choice theory. I'm not such a person. I don't know. I just can't tell you.
But these conclusions contradict each other.
Yes, but what I was looking at was systems where you get contradictions in virtue of the meaning of the logical operations. And this can happen even if you nevertheless are not able to derive any conclusion whatsoever. So you can have this without trivializing the logic. And that's what I wanted to make sense of. I want to make philosophical sense of it. And so rational choice theory, yes, is something where I am really lack expertise, I must say. I can tell you.
Thank you for your explanation.
Yeah.
Thank you, and organizer of our discussion today, really meeting, Helena Mishalova, please, your question and comment.
Thank you very much for interesting talk. And my question risk being too simple, but nevertheless, I would like to raise it. What do you understand under information and under preservation of information? Why I'm asking, because I think it's this idea about preservation of information is in the controversial context is very interesting for history as a discipline, because what we have in history is a lot of information from different sources, and we have several narratives which organize this information and transform into knowledge. And often these narratives are very, very controversial. I mean, they present different interpretation, different explanation of the same events. And in my view, it's good and to some extent desirable situation. And there is no need to reduce them to one standard narrative. So I think it's also a kind of preservation of information. So what do you understand under information and preservation of information?
Yes. What is preserved then in a valid inference in, for instance, this logic C is that the statements receive support of truth. So suppose you have some data and they are given to you in the sense that these statements are told true. They are presented to you as told true, and then you can apply the logic to figure out what therefore is also told true. It may not be obvious to you. So you may have a number of statements that are given to you, and then you may wonder, okay, if someone proposes these statements, or yes, so what is thereby also put forward as true. And so you can make up your mind and see what is in that sense implied. So it's not that that this guarantees the truth, because what is told true may be false. But it's kind of yes. I'm afraid I cannot say much more in addition to this, except also that on this bilateralist approach, where that you can see also in the logic that I presented. I mean, truth and falsity, or support of truth and support of falsity, are treated on a par. So you can also, okay. Actually, there was a slide that I stopped the sharing, I think. Okay. Anyway, so on one of the slides that I skipped, I said that in addition to preservation of support of truth, you could also consider preservation of support of falsity. But you can also mix it. If you have this negation that toggles from truth to falsity and back and forth, then you can consider the situation that you are that some assumptions receive support of truth, some receive support of falsity. Hey, and then you can see and look whether a certain conclusion receives support of truth and support of falsity. So there's a kind of mixture of these two reasonings, and I'm not sure whether this really answers your question, Alan. But what is preserved is that yes, that statements receive some support of truth or falsity. Both are treated on a par as equally important, and semantic dimensions in their own right.
Can we call it possibility of truth, for example?
No, I think we cannot, because this would somehow, I mean, okay. we can draw the distinction between possibility of truth and possibility of falsity. So you consider statements that are of course, we could think of the case that statements are told as contingently true and told as contingently false. I did not have modal operators in my vocabulary. So maybe this could be an extension of what I presented. But if you think of an elementary statement as told true, the idea is not that it is presented as possibly true or as possibly false. It is really, the idea is it is told as true. It's told true. It's claimed to be true in a sense. But this metaphor is, of course, also a bit dangerous. I mean, it's not about speech acts. This told metaphor has some problems, as most metaphors have, but they are also often good for something. And I think the told metaphor is really helpful. But no, I would not say that this told true could be read as told as possibly true. No. But maybe if you take an extended language where you have modal operators, and you can tell statements of the form necessarily true as true, or possibly true as you can tell them false. Yes, then you can raise questions whether support of possible truth is preserved or support of necessary falsity is preserved, something like that. Yes.
Thank you.
Thank you. Thank you so much. Any questions, comments? Do you see we 2 hours we are talking and discussing, and it's really such as 1 minute, and at the same time many topics, many information, and many reason for future discussion.
I want to say one more thing, namely, thank you very much for your questions. There were some hard questions and difficult questions. I'm sorry that I couldn't answer all the questions, but I really enjoyed the discussion. Thank you.
Yes, but it's a real discussion, not something artificial. Thank you so much. We are happy to see you with us, and I suppose it will be only beginning of our communication. Please be with us. Your speech is amazing, and I agree with my colleague from Odessa, Dmitry Lishenko. We're happy to use your presentation as a material for students, for colleagues. We maybe after some minutes we will finish our meeting today, but we will continue to think about. Thank you so much. And I would like to, I'm happy that we have this springtime of our seminar. We are with a great, brilliant philosophers, logician, specialists in the theory of argumentation and analytic philosophy. And I would like to invite you to our next session, May. It will be 21 of May, and it will be a meeting with the Professor Richard Feldman, who are specialists in the theory of argumentation. And it's a very special event for us because it's a reaction on the publishing of the or translation collective paper on theory of argumentation that was proposed by Professor Christoph Lumer and translated into Ukrainian for all of our colleagues by Professor of Department of Philosophy, Odessa National University, Sergei Sekundant. And we are happy to continue to present this publication and to talk about one of the most important problems of the contemporary theory of argumentation. And my invitation to my colleague to present some books in Ukrainian, important, and to continue this dialogue. First of all, I look on my colleagues from Kryvyi Rih, it's an amazing volume devoted to the legacy of Karl Popper. I would like to discuss it in our future, but it's maybe proposition for our future meeting. But today we are full of information, ideas, and inspiration. Thank you so much, Heinrich Wansing, Professor Heinrich Wansing. We are happy to invite you again and again. Thank you.
Thank you. Goodbye.